So now we'll be looking at Venn diagrams. So what are Venn diagrams? So a Venn diagram is a graphical representation of sets. It shows the relationship between subset and universal set. So to give you a very broad idea of this, I'm going to quickly be explaining some vital components. So first, you have a box where you want to draw the in the Venn diagram. So the box represents the universal set. So in the universal set, as you can see, it now contains the subset, that is smaller subsets that are within the universal set. So what we're going to be doing now is to define some concepts relating to Venn diagram. So first, let's start with the definition of the universal set. So the universal set is made up, as we know, of the set that contains all elements. So all subsets, in this case you have subsets A and B, so they are all contained within the universal set. So now this is the universal set. Also in a situation where you have three subsets, as you can see, A, B and C, then you can see how they are drawn. You draw them to intersect one another, but the universal set contains all the elements that are within that subset, and even the other elements that are not within the subsets but are in the universal set. So let's talk about some parts of the universal set. So what is the complement in terms of the Venn diagram? So if, for example, let me start out by drawing a universal set now. So let me assume a universal set and in which I have only one subset A. So if I have a subset A, so all elements, what do we define as complement? We said complements are all elements that are not within A but are in the universal set. So everything that is not within A but are in the universal set is referred to as the complement of A. So the complement of A, now this is A, be everything that is outside of A. So as you can see, everything shaded in blue is the complement of A. So in this same fashion, the complement of B in this case is everything outside of B. So this is the red line representing B. So everything outside of B is the complement of B. And in this case now, the complement of C will be everything outside of C. Now this is the line representing C. So everything outside of C is the complement of C. So everything outside of C is the complement of C. So everything outside is the complement of C. So now let's talk about the concept of union. So as we said before, what does the union of a set mean? So union of a set means the elements that are contained, all the total elements between two sets. So for example, in this case, if I have set of elements of A and set B, so A union B represents the elements that both contained in A and B. So it represents the area under these two cycles. So A union B will be everything that is underneath these two cycles, since union tells us to add. So now let's look at this other Venn diagram here. So what will be A union C, for example? So now we know that this is my A, this is my element or my subset A here, and this is my subset C here. So A union C will be all the elements that are contained within both sets, and that can be defined by the shaded portion. So everything that is within those two cycles define the union A union C. How about A union C union B? So now it contains all elements within A, B and C. So I have to shade through everything. So A union B union C, as represented by the green part, is given as this: all elements within A, B and C. Now what about the intersect? So as we said before, intersect represents the elements that are common to both sets, So in this case, A intersect B refers to the sets that elements that are common to A and B. So in this case, you have A here and you have B here. So where is the intersection? You can see that the point of intersection is this area under here. So this portion under here represents the intersection of A and B. So now let's look at another example making use of this portion. So now what would be A intersect C? So now we say A intersect C. First we have to identify A, which is this, and we need to identify C, which is this. So A intersect C refers to the area in which those two circles connect with each other, and that will be defined by what? By what is in between here. So that gives us idea of A intersect C. And to explain the concept of say A intercept B intersect C, so what portion of this diagram connects everything together? So to do that, we are going to start out again by identifying each portion. So we have A as here, and we have C as here, and we have B as this. So what portion connects the three circles together? As you can see, it is in this portion here that the three circles meet with each other. So this area under this curve here represents the intersection of A, B and C. So how do we use this to solve questions? So for example, let's try to look at this example, and it tells us to identify A union B, then everything intersects C. So as we know with our board maths, we first have to find A union B. So as I've explained before, A union B is made up of all elements that are in A and all elements that are in B. So I'm going to shade that now with an orange line. So this represents A union B. Everything orange that connects both A and B, as you can see. So this represents A union B. So now we are told to find the intercept of A union B with C. So the next thing I have to do now is to shade subset C because I'm looking for, so I have to shade subset C, and I'll shade it with a blue line. So I'll shade it like this. C is made up of this portion here. So as you can see. So now by the definition of intercept, what does the intercept mean? Intercept mean what the two of them have in common, and to decide what the two of them have in common, it just represents the area in which the orange line intersects with the blue line, and I'm going to represent that with a green, and you can see that it is this area in which that occurs. So here represents A union B intersect C. So A union B intersect C is this region over here. So how do we use this to solve questions? So now this is an example of a past question. I'm going to try to solve that. Say, which of the Venn diagram below represents P complement intersect Q intersect R complement? So what are we going to do now? We're going to try to see if we can sketch this out. So let's try to sketch this out. So start out by drawing the universal set like we already know. So you draw that out and you write out the elements or the subsets rather. You draw them out. So you have P and you have Q and you have R. So I have P and I have Q and I have R. So first I need to identify P prime or P complement, and as I have defined before, P complement represents everything that is not in P but is in the universal set. So I'm going to represent that with a wide line. So P complement is everything that is not within this cycle. So that will be every portion that I'm trying to identify. So everything like this represents P complement. So let me try to be fast about that. So you have this. So, and if you will notice very well, I shaded everywhere in the universal set apart from the inside of P. So that is what the complement of P, everywhere apart from the inside of P. So now what does Q represent? Q represents, and I'm going to do that with an orange line now. So Q now represents the elements within this region of Q. So I'm going to do that with an orange line. So this represents Q. As you can see, the orange line. And finally, I'm trying to find R complement. So R complement, let's do that with a red line. So for my R complement now, which I'm trying to find, R complement refers to everything that is not in R. So now to do that, I will do that with diagonal line. Now you can see now that everything, so I'm going to shade everywhere apart from everywhere that fall within R. So I'm not going to shade any portion within R. And when I do that, the question now asks us to find the intercept of everything. So what do I have to do? I just need to look for the region in which the white line and the orange line and the red line intersect. And if I look at it carefully, it is only within this region that I have those three lines intersect with one another. If you look at this region here, you have only the red and the orange, the white and the orange. In this region here, you have only the orange. In this region here, you have only the orange and the white. But in within here, you have the red lines, you have the orange lines, and you have the white lines. So this will just be denoted by this region over here. And what option corresponds to that? That would be A. So the correct answer to this question is what? Is A. So let's move on to another example that has to do with Venn diagrams. It says, in a class of 46 students, 22 play football and 26 play volley. If 3 students play both games, how many play neither? So first, you have to start out by drawing out or representing the information in a Venn diagram. But here we have just two subsets, and we're told that the universal set total number of students is just what, 46, and in the subset we just have two sports being represented there. You have football and you have volley. So you are told that the number of people that play football is 22. That means the area underneath this cycle is 22, and the area underneath this cycle for volley is 26. Now we are told that if three students play both games, that means the intersection of football and volley, which is represented by this area here, represent the students that participate in both activities, is made up of 3 students. Then how many students play neither? So as we know, how many students play neither refers to the complement of these two sets. So the complement of A union B will be everything outside of here. So this is what I'm told to find, because this represents the complement of F union V, and they represent the students that don't play anything. So as I know, those that play nothing and those that play football and volley plus those that play both of them will give me the number of students in the classroom. So now I know that the total number of students that play football are 22, but I know that out of those 22 that play football, 3 of them are also playing volley. So what does that tell me about the students that play football alone? So to find the number of students that play football alone, it will just be which is represented by this section here. I just have to multiply the students that play both of them away from 22, and that gives me 19. So what does it mean? It means that out of the 22 students that play football, which is represented by this cycle over here, that 19 of them only participate in football, while 3 of them participate in both football and volley. So I'll apply the same logic to this section over here. I'm told that 26 students play volley, but out of these 26 students that plays volley, 3 of them also plays football. So how would I find the number of students that play volley alone, which is represented by this section? So I just have to minus 26, 3 from 26, and that gives me 23. So what does this mean? It means that out of the 26 students that play volley, that 23 of them play volley alone, volleyball, while 3 of them play both football and volley. So now, as I've mentioned before, the number of students that play football alone only, plus the number that play volley only, plus the number of students that play both, plus the number of students that don't participate at all, which I'm looking for, neither plus neither must be equal to the total number of students in the class, in this case, which is what? 46. So the number of students that play football alone is 19. Number of students that play volley alone is 23. Number of students that play both of them is 3. And I'm looking for the number that play neither, which I will call n, must be equal to 46. So 19 plus 23 plus 3 gives me 45. Then plus n is equals to 46. So I know that my n will be equals to 46 minus 45, and that is equals to 1. So the number of students that doesn't participate in any sport is 1, which is A. Now let's move on to another example. So now in this question, now we are told that in a survey, it was discovered that 76 like history, 98 like geography, and 87 like mathematics, 15 like all 3 subjects, 39 like history and geography, 37 like history and maths, 48 like geography and maths, and 45 like none. Show this information on the Venn diagram. So how is it going to look like? So let's draw that in the next page. So we are told that 46 students, so this is our universal set now. Let me make it very bold. So we are told that 46 students play history, and we have 3 sports. We have 3 subjects. We have history, we have geography, and we have mathematics. So we have history, geography, and mathematics. So the number that plays history is what? 76. Geography is 98, while maths is 87. So we have 76, 98, and 87. Now we are given some more information. We are told that 15 like all 3 subjects. So what does it mean? It means that the intersection of the 3 of them is what? 15. So 15 of them participate in all sports, and this is the intersection that represents all the 3 subjects. So 15 of them participate in the 3 subjects. Now also, what are we given? We are told that 39 like history and geography. So what does it mean? It means that the intercept of history and geography, history intercept geography, is equals to what? 39. Now we are also told that 37 like history and mathematics. So the intercept of history and mathematics is equals to 37. And finally, we are told that 48 like geography and mathematics. So the intercept of geography and mathematics is equals to 48. And finally, we are now told that 45 like none of the subjects. So what do we do about none? None represents the area that is not within any of these subsets. So that will be outside here. So that means number that like none is what? 45. So what is our goal, or what is the question that was given to us? We are told to calculate the number of students that took part in the survey. In other words, we are told to find the universal set U. So we are trying to find the universal set. So how will we calculate the universal set? We know that the universal set is equal to the area under this curve, and the area under this box is defined by the total number that participated in none, which is 45, plus the area of all these circles here. So what are we going to do? We are going to try to look at the area between each of these space that is given here. So this space here, what does this represent? 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 And what does this represent? If we sum everything together, it will give us the universal set, which represents the number of students that participated in the survey. So to start out, we are told that 39 students participate in both history and geography. So let's look at the intercept between history and geography. We know that the intercept between history and geography, which is given by this section, is what? Is 39. And if it is 39, then what does it tell us? Then, and we know that 15 out of them participated in 3 subjects. So the students that participated only in history and geography will be 39 minus 15, and 39 minus 15 gives me 24. So the section underneath this place, this section here, is what? 24. Now I move on to the next information. I'm told that the intercept between history and mathematics is 37. So the intercept between history and mathematics is given by what is here in this orange line, and I'm told that the area underneath here is what? 37, but a small fraction of it is 15 because this portion represents students that participated in all 3 subjects. So what am I left with here? I'm left with 37 minus 15, and that gives me what? 22. And finally, with the last information I'm giving, I'm told that G intercept M is 48. So this section underneath here is given by what? 48. And I'm told that 3 of them like 15 of them like the 3. So the portion remaining here will just be 48 minus 15, and 48 minus 15 will just give me what? 33. Yes, I'm not mistaken. So now we're just left to find the areas year, and year. So now we are told that the number of students that like history is 76, but this 76 now is made up of everything within year. But out of everything within year now, we know that this section represents 24, this section represents 15, and this section represents 22. So the section remaining here will just be 76. So history only now will just be what? 76 minus 24 minus the sum of 24 plus 15 plus 22, and that gives me what? 15. So now we move on to the next. So now for geography alone, let's represent it with this green line over here. So now we are told that total number that like geography is 98, but it comprises all this cycle. But we know what the smaller fraction are, so we can calculate what is within here. So we know that geography only will be given by what? 98 minus the sum of 24, then plus 15, and plus 33, and that gives me 26. So what I have here is 26. So I forgot to put that here, I have 15 here. And finally, for the last one now, I'm going to use a verb to represent it. So for the mathematics, which is denoted by this verb, I'm told that 87 students like mathematics, but it comprises of students that like both history and maths, and this section and this section. So to get people that like mathematics only, it's just going to be 87 minus the sum of those other numbers that I've gotten, which is what? 22 plus 15 plus 33, and that gives me what? 17. So I know that here is 17. So now I know that the universal set is made up of the sum of all these numbers in within here plus the sum of students that didn't take any subject. So the universal set in this case now U will just be equals to 15 plus 24 plus 15 plus 22 plus 15 plus 22, then plus 26 plus 33 plus 17 plus 26 plus 33 plus 17, and plus the number that participated in NIDA, which is 45, plus 45, and that gives me, when I sum these numbers together, 197. So the total number of students that participated in this is what? 197. So this gives you a pretty broad idea of how to use Venn diagram to solve past questions. But I should mention that in JAMB, you would hardly find questions that are this complicated. Most of the times, the only one you will find are ones that have just 2 subsets within the universal set. So that will be all for now.